Okay, so we're writing a recursive algorithm that replaces each single binary tree node with multiple nodes with smaller values. The new cloned nodes should extend from their parent in the same direction. So I'm just gonna go over this example real quick here, where the value k is 2. So this means that we need to clone each node in the original tree twice and replace the original value with 1 over kth of the original value. So in this case, we replace 12 with 6 and clone 6 twice, so on and so forth. So I think the important thing to notice here is that we need to figure out which direction to extend. And the question has stated that we need to extend in the same direction from their parent. So for example, 81 is the left child of 12. So that means when we clone 81 with new values, those new nodes should extend to the left. In this case, 40 is extending the left. Same thing with 34. When we clone the new values of 34, we need to extend it to the right, since 34 is the right child of 12. So from this, we can tell that we will need an additional argument in our recursive algorithm to let our algorithm know that whether if we need to extend to the left or extend to the right. We will create a helper function that takes in a node parameter and also a Boolean value here. I'll call it is right. That tells us whether if we should extend to the right or left. So next I'm going to go over this example here where k is equal to 2. So when we traverse the tree, I am using the post-order traversal. Okay, so that means we're going to visit the child nodes first and then the parent node. In this example here, since this is null, that means we're going to visit 56 first. We're going to visit the right child first, 56. Right, so in 56, first what we're going to do is we're going to replace 56 with the new value. And the new value is 28. And then we're going to extend to the right again, since k value is 2, right? Then now we have this new clone values, 2 28s. Now we're going to go back to the parent node, 81, and do the same thing, right? Replace the original node with a new value. In this case is 40. And then extend it to the left, since 40 is the left child of 12, right? So if we do that, then that means our new node here would be 40. But the thing is, we need to make sure that this child here is to the right of the leaf node 40 right here. So that means what we just did is not correct. So if I just go back to what we originally had, so we had 81 before. So in order to move this part to the correct position, what we want to do is we need to have some variables to reference them. It's called temp1, and we'll have temp1 reference to the child of 81, and then temp2 to be the reference of the left child of 81. Now in this case, we can access these temp1 and temp2 variables later to make them to go to the right position. Right. So once we do that, then what we can do is we want to erase this edge so that it's pointing to null. Right. Since when we are expanding 81, we don't want the very first cloned node to have any right child. We want that child value to be at the last value of the cloned nodes. So basically what I'm going to do here is set the right child to be null and also the right child to be null as well. So we can erase that edge. Right? Okay, now from here, we can start cloning 81. So replace the value to be 40 and then clone it again. right? So now we constructed 40. Now once we're at this 40 here, then we can set the left and right child to be temp1 and temp2. So in this case, the left child is temp2, which is pointing to no, and then the right child is temp1, which is this value here, and that's what we wanted. So we just need to do this for the rest of the nodes now, right? I'm going to erase these real quick. So if we follow our tree traversal post order, then now we're going to be to some operation on the number 19. So if we do the same thing, we'll have temp1 to point at the right child, right? And then temp2 to point at its left child, which is no. And then also making sure that we set the original node, its left and right child, to be no. And then from there, we will start doing the cloning. First, replace the original node value with the new value, which is 9. And then clone it again. Now set its left and right child to be temp1 and temp2. And in this case, they're both no. Now we're going to go to the right child. It will be the same thing. I'm just going to quickly do this one real quick. So yeah, it's pointing at no, pointing at no. Okay, so now we're at 34. Right, so we would do the same thing. Temp1 is its right child, temp2 is its left child. And then we would erase this edge here and this edge here and making sure those are pointing at no first. Once it's pointing at no, then we can do the clone operation. In this case, it will be 17. And this time we will expand to the right. So 17 here. So now, once we're at here, then we can say its right child is pointing at temp1. Its left child is pointing at temp2. That's what we wanted. Now we're going back up to the last node, which is 12. Do the same operations again, where we say temp1 is the right child, temp2 is the left child. Erase these two edges, making sure that they are pointing to no, and then do the clone operation, which is 6. Expand to the left, since this is the initial node and by default is to the left, and then pointing this 6 here to temp2 for its left child, and then for its right child is temp1. And then this will be our last, this will be the final binary tree here. All right, now let's go over the code. So we have a TreeNode here, value left and right. And then we have a function called stretch that takes in the root of the TreeNode and a k value. And within stretch, we will basically just call the helper function by passing in the root value and false, indicating that we want to expand to the left. Right? So for this helper function here, we are doing post-order traversal. So the base case, we're checking if the node is none. So if it is none, then we will just return. And then from there, we will basically recursively call the helper function with its left child and right child. If it's left child, then we will pass in false. If it's right child, then we pass in true. Then we will set the node value to be the new node value. And from here, I'm going to quickly go over a example while I am walking through the code. Let's say we are at 81 and we just finished expanding 56. We just finished expanding 56 and that turns into 28 and 28. And now we're at 81, right? As you can see, we set the node.value to be the new node value. In this case, this would be 40, right? And then we set temp1. We set temp1 to be the right child, temp2 to be the left child, right? And then we are erasing or removing these two edges and making sure that they are both pointing at no. Then, starting at line 101, we would iterate through the loop k-1 times to clone the nodes. So we would create a new node with the new value 40, then check whether it was right or whether it was left. In this case, we would be expanding to the left. So therefore, we will go to the else statement and then say that cur.left is equal to new node. And initially, the cur, as you can see from above, cur equals to node. And remember, we are at this node here. So cur.left is equal to 40. So now, instead of pointing at no, it's pointing at 40. And then we will move the cur value to the left. So cur equals to cur.left. We shift this pointer to here. Right. And once the cur value is at this node here, then our for loop breaks out. Then we will set cur.right to be temp1. In this case, temp1 is 28 and 28. And then cur.left equal to temp2 would be no here, like that. Right. And then after that, we will return back to the parent, and then we will go all the way down to the other side of the tree and start doing this operation all over again. And that would be the final algorithm. Thank you for watching, and let me know if you have any questions.